Hello, and welcome to Week 2 of the MMS 211 fabrication class at Lorain County Community College. Last week, we discussed microchips and their use in the semiconductor industry. In this video, we will focus on the silicon substrates from which these microchips are manufactured. These substrates are otherwise known as wafers. So how are these silicon wafers made? The basic material used for production of wafers is silicon. Because the raw silicon material consists of multiple crystals, we call it polysilicon. This polysilicon material goes through a special fabrication process, during which it is made into columns of ultra-pure silicon, called ingots. These ingots are grown from a single crystal. Finally, the single crystal ingots are sliced into wafers. Now, let's look at how the raw silicon material, which consists of multiple crystals, is processed into a single crystal ingot. We will look at two methods that are frequently used in the semiconductor industry. The first one is called Czochralski process, and the second is called float zone process. Czochralski process was created by a Polish chemist, Jan Czochralski, in 1918. It is a method to grow single crystal silicon. Highly purified silicon is melted in the temperature of 1500 degrees Celsius. The seed crystal, that is mounted on a rotating shaft, is dipped into the molten silicon. The crystal is counter-rotating and pulled upwards, allowing the formation of a large, single crystal cylindrical column from the melt. This big, single crystalline silicon block is an ingot. Through this method, we can process crystal ingots with a diameter of 300 mm and with length of 2 meters. The float zone process is a newer method of making ingots. It uses the same melted silicon, but it also uses magnetic field and coil. The process starts with a polycrystalline ingot. The end of the rod is heated up and melted using a radio frequency heating coil. The melted part is put in contact with the seed crystal, and the atoms realign, after they melt, into the single crystalline state. As the molten zone is moving along the polysilicon rod, the single crystal ingot is growing as well. Finally, once the single crystal ingot is grown, it is then sliced by a very sharp diamond saw into thin wafers. The dicing process is a very delicate operation. The sliced wafer is 775 micrometers thick and 300 millimeters in diameter. Nowadays, wire saws are used more frequently, rather than the previously used blade saws. In fact, the semiconductor industry is now moving to the wire saw, due to their superior technology. This brings us to the end of today's presentation. Today, we have explored the process of making silicon wafers, and two processes for growing single crystal silicon ingots. Thank you for your attention.